Problem statement. The total power consumption in one building determines as whole, making it difficult to identify the power consumption for each department in the building. Implementing a power usage monitoring system in a business office complex can have a significant impact on cost savings and energy efficiency. By identifying areas of energy wastage and optimizing energy usage, businesses can reduce overall consumption and lower their energy bills. Continuous monitoring of energy consumption enables businesses to identify areas for improvement and maintain long-term cost savings. The power usage monitoring system provides real-time data on energy consumption, allowing businesses to identify inefficient usage and take proactive measures to optimize energy usage and reduce their carbon footprint. Furthermore, a power usage monitoring system plays a crucial role in predictive maintenance. By analyzing power consumption patterns, the system can detect anomalies and predict potential equipment failures before they occur. This proactive approach helps businesses avoid costly downtime and repair expenses, ensuring smooth operations and enhancing safety. Real-time monitoring of power consumption, facilitated by IoT technology, offers immediate detection of power outages, surges, or irregularities. This protects electrical equipment from damage and ensures uninterrupted power supply. By promptly alerting maintenance staff to potential issues, businesses can take immediate action, minimizing downtime and equipment failures. Objective: System design. We will discuss the meticulous design process involved in creating an efficient and effective power usage monitoring system. This includes the integration of current transformer sensors, which accurately measure power consumption, and the incorporation of IoT technology for enhanced monitoring capabilities. Sensor selection and integration. We will delve into the careful selection of current transformer sensors, considering factors such as accuracy, reliability, and compatibility. Furthermore, we will outline the seamless integration of these sensors into our monitoring system, ensuring accurate data collection. IoT integration for enhanced monitoring. Exploring the power of IoT, we will showcase how our system harnesses its potential to enable remote monitoring and control. By incorporating IoT connectivity, our system offers real-time monitoring, allowing users to track power usage and make informed decisions for energy optimization. Data collection and analysis. We will highlight the significance of data collection in power usage monitoring. Our system collects power consumption data at regular intervals, facilitating in-depth analysis. We will discuss the algorithms and techniques employed to process the data and extract valuable insights into usage patterns and trends. Data visualization and reporting. Effective visualization is key to understanding and utilizing power usage data. We will showcase our system's user-friendly interface, featuring visually appealing graphs, charts, and dashboards. Additionally, automated reporting capabilities will be demonstrated, providing concise summaries of power usage statistics and trends. Real-world testing in a business office complex. We will share the results of this testing, highlighting how our system successfully monitored and optimized power usage in this setting. Limitations: the project. Accuracy of data. The system's effectiveness relies on the accuracy of the data collected. Any discrepancies or inaccuracies in the data sources could affect the reliability of the analysis and recommendations. Compatibility and integration. The system's scope may be limited by the compatibility and integration challenges with existing power infrastructure and metering systems. It may require cooperation from utility companies or access to specific hardware for seamless data collection. Privacy concerns. Power usage monitoring involves collecting data on individuals or organizations, which raises privacy concerns. The system must adhere to data protection regulations and ensure that sensitive information is securely handled and anonymized when necessary. Cost and affordability. Implementing a power usage monitoring system can involve upfront costs for hardware, installation, and software development. The scope may be limited by budgetary constraints, particularly for individuals or small businesses. The flowchart begins with the "Start" symbol, indicating the beginning of the process. Design 3D printing using SketchUp. This step involves using SketchUp or a similar 3D modeling software to design a 3D model of the object we want to print using a 3D printer. Assemble all component figures in schematic diagram. Once we have the design, we create a schematic diagram that represents the various components needed for our project. Connect all components based on schematic diagram. Try and error to complete the circuit. After connecting the components, we may encounter issues or errors in the circuit. This step involves troubleshooting and making adjustments to fix any problems or improve the circuit's functionality. Circuit complete and working, yes. If the circuit is complete and functioning correctly after the troubleshooting process, we proceed to the next step. Try and error to run the code. This step involves writing the source code for our project, which include programming languages C. After writing the code, we need to test and debug it to ensure it runs as expected. Successfully run, yes. If the code runs successfully without any issues, we move on to the next step. Upload the source code into the 32 Spanish pesetas. This step involves uploading the source code we wrote onto the 32 Spanish pesetas board. Design PCB board. A PCB, printed circuit board, is a physical board that provides a platform for mounting and connecting electronic components. This step involves designing a PCB board specific to our project, which will serve as a more permanent and efficient solution compared to breadboarding. Get the PCB board and test the connection. Once the PCB board is designed and manufactured, we test the connections to ensure everything is properly connected and functioning as intended. Deploy the project. If the connection tests are successful, we proceed to deploy the project, which means putting it into action or using it in its intended environment. Project runs successfully. Yes. If the project runs successfully in its deployed state, we have achieved your goal. Deploy the project. No. If the project does not run successfully, we may need to go back to the troubleshooting stage or make further adjustments to ensure proper functionality. End. The flowchart ends with the end symbol, indicating the completion of the process.
With the aid of the cutting-edge Fusion 360 software, we have ingeniously crafted a highly functional and visually appealing 3D design for an ESP32 and LCD display case. Meticulous attention to detail was employed during the creation of both the case bottom and top, guaranteeing precise measurements and impeccable compatibility. Upon finalizing the design to perfection, we seamlessly transformed it into an STL file, which is now primed for the transformative world of 3D printing, bringing our innovative vision to life.
Integration Akli and Nikli. Environmental stewardship. Islam encourages its followers to be responsible stewards of the earth and its resources. Monitoring power usage can help individuals and communities become more conscious of their energy consumption and promote sustainable practices, aligning with the principles of environmental preservation found in Islamic teachings. Accountability. Islam emphasizes the importance of being accountable for one's actions and using resources judiciously. A power usage monitoring system can help individuals and organizations track their energy usage, identify wasteful practices, and make necessary adjustments to ensure efficient utilization of resources. Social responsibility. Islam places great importance on caring for others and promoting social justice. By monitoring power usage, individuals and organizations can identify opportunities to reduce their energy consumption, minimize their carbon footprint, and contribute to a more sustainable and equitable society. We employ fritzing software for our schematic design requirements, specifically to construct diagrams. Fritzing stands out for its user-friendly interface, making it a breeze to use. In regard to the project's financial aspect, the total budget allocated amounts to $261, while the provided budget for the project stands at $500.
Okay, now we will show how the power usage monitoring system works. Okay, before starting the demonstration, we will refer to the LCD. This LCD, how many readings or the readings before we connected to power for our hardware. And before that, we get the power from the socket. And connect to the hardware that we prepare. And before we connected to the power, we can see that from the LCD, the IRMS is 0.0168 amps or 0.03, and the power is 0.035, and kilowatt hour is 0.01, and also at the blink.
Actually, when we add some load into the generated power, we can know that the power, kilowatt power, and current will be increased based on our load that we consume. So the first thing, after we know that the current starting from the zero value, when we add the pentaflow lamps, right? When we add loads by on the switch of the pentaflow lamps, alright, we will see the increment of the current RMS, and the power of and the kilowatt power will increase based on one load that we add. Okay, now when we add some load into this socket, we will see the increment of the power of the current, and the kilowatt per hour will also increase based on our load. We know that when the all load connected based on the what that we made, we see that the increment of the power and the kilowatt per hour is high. So we know that when the department, based on department, we know that where the department that use many loads based on the power monitoring system that we made.
Significant project. Implementing a power usage monitoring system in a business office complex can have a significant impact on cost savings and energy efficiency. By identifying areas of energy wastage and optimizing energy usage, businesses can reduce overall consumption and lower their energy bills. This can be achieved through various measures such as upgrading lighting systems, improving insulation, or adjusting power schedules based on occupancy patterns. Continuous monitoring of energy consumption enables businesses to identify areas for improvement and maintain long-term cost savings. The power usage monitoring system provides real-time data on energy consumption, allowing businesses to identify inefficient usage and take proactive measures to optimize energy usage and reduce their carbon footprint. In today's environmentally conscious world, efficient energy use is essential. Power usage monitoring systems generate extensive data that can be analyzed to identify consumption patterns and trends. This data analysis helps businesses and households identify areas for improvement and optimize energy usage further, resulting in reduced consumption, cost savings, and minimized environmental impact. Therefore, leveraging data analysis capabilities of power usage monitoring systems is crucial for achieving efficient and sustainable energy use. SDG Element 1. Affordable and clean energy, 7 Sudanese pounds. Power usage monitoring systems can help households and businesses reduce their energy consumption, promoting affordable and clean energy usage. This supports SDG 7's targets of increasing the share of renewable energy in the global energy mix and doubling the rate of improvement in energy efficiency. Sustainable cities and communities, 11 Sudanese pounds. Power usage monitoring systems can help cities and communities become more sustainable by reducing overall energy consumption and promoting the use of renewable energy sources. This supports SDG 11's targets of making cities and human settlements safe, resilient, and sustainable, and promoting sustainable transportation systems. Climate action, 13 Sudanese pounds. Power usage monitoring systems can contribute to climate action by reducing greenhouse gas emissions associated with energy consumption. By promoting energy efficiency and renewable energy use, power usage monitoring systems can support SDG 13's targets of reducing greenhouse gas emissions and building resilience to the impacts of climate change. Responsible consumption and production, 12 Sudanese pounds. Power usage monitoring systems can support responsible consumption and production by promoting energy-efficient behaviors and reducing waste associated with energy consumption. This supports SDG 12's targets of reducing waste generation and promoting sustainable consumption and production patterns. Thanks for watching.